Section 1.1b, Pre-Calc Review 1 continued. When we left off in the last lesson, we finished off with rationalizing the denominator. A quick note that rationalizing doesn't necessarily always have to occur to the denominator. You could also rationalize the numerator. Use the same sort of logic. So if you have something like 2 divided by the square root of x, what we did before for the denominator was we multiplied by 1, we multiplied and divided by square root of x. So on the top you get 2 times root x all over x, because the square root of x times the square root of x is the square root of x squared. We're assuming x is positive, and we get that to work out. But this was for the denominator, because the radical was in the bottom. If you're asked to rationalize the numerator, suppose you have a question like 5 square root of x divided by 3. Then in this case, you're going to need to rewrite this as 5 root x over 3 times root x over root x. Okay, so the radical was in the top, and you're trying to get rid of that by multiplying by root x. So on the top you just get 5x divided by 3 root x. So essentially, when you rationalize the numerator, the radical disappears from the numerator but shows up in the bottom. And if you rationalize the denominator, the reverse happens. Alright, so in the second half of 1.1, we primarily look at polynomials and algebraic expressions in general. So that's the first thing we'll talk about, is what is a polynomial. So quick review, you might want to look up the textbook for more details. This would be on page 8. Polynomial is an algebraic expression that has nice terms, in the sense that every term has this form: a constant times a variable to a nice power, where n is a whole number. So for example, x squared plus 3x minus 2, that's a polynomial, because every term, every exponent is good, a nice whole number. On the other hand, if you had something like x to the half plus 4x minus 8, that is not a polynomial. Why? Because of the exponent half. It's not a whole number. Okay, so you have the concept of adding, subtracting, multiplying polynomials, and factoring polynomials. So all this is going to be explained as we do the worksheet problems here in just a few minutes. Something else that you may recall from algebra is the concept of factoring, GCF, the greatest common factor, etc. The GCF, greatest common factor. You may recall FOIL, when you multiply, and reverse FOIL, all that good stuff. Again, the book has a whole bunch of formulas for you to look at. I'm going to move on and do the worksheet here in just a minute, but the next part of this section, as far as the lecture topic goes, would be solving polynomial equations. Solving polynomial equations. And this can be done in a couple of ways. At this level, we'll be either doing it by factoring, solve by factoring. Again, examples will be done shortly. Or if you have a quadratic equation that cannot be factored, solve by using the quadratic formula. And hopefully you remember that. You need to have this committed to memory. So the quadratic formula is, if you have a quadratic equation, ax squared plus bx plus c is 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so this is the basic idea behind this section. Let's do some problems now. So we have in this worksheet, which you can print off and follow along or work on your own and check with my video. So here you have a polynomial, nice powers, another polynomial, and you're adding, so it says perform the indicated operation. So you're not multiplying as some students tend to do, rather you're adding. And how do you add? Well, you just add the like terms. 7x squared and 2x squared combined to give you 9x squared. And then you have negative 2x and 5x, they're like terms, so that's positive 3x, and then 5 minus 4 is 1. That's it. Don't go any further. For this question, before you can actually simplify, you need to first distribute. So 3 gets distributed. You have 6x minus 3y. Minus 4 gets distributed. It's 4y. But here it's negative times a negative. Distribute the 2 and get positive. 4 times 2 is 8, so it's 8x. Now for this problem, you can go further because you still have like terms to combine. 6x and 8x gives you 14x minus 7y. That's 7y is from these two terms. The next question looks a little messy with all the fractions, but the idea is the same. You have like terms, the x terms, negative 7/4 plus 3/4. Well, 4 is a common denominator, so negative 7 plus 3 is negative 4, so it's negative 4/4 x. And then for the y terms, it's positive half, take away a quarter. Half minus a quarter is a quarter, so it's a 1/4 y. And then you have positive 120 minus 200, that's a negative 80. Okay, so technically you're done, but you really should go a little further because negative 4 over 4 is just negative 1, so it's negative 1x plus 1/4 y minus 80. Alright, so this is the answer. Over here, that's the answer, that's the answer. For the next question, you're actually multiplying two polynomials. These are binomials because they have two terms each. And to do that, you use a distributive property. You take this x, fix it, distribute it. X times x is x squared. X times 7 is negative 7x. 3 times x is 3x. And 3 times negative 7 is negative 21. So it's x squared minus 4x minus 21, combining like terms. Alright, the next one, the mistake you do not want to make here is just to square each of those terms. That was a cautionary note in the last lecture. Instead, because it's an addition, you don't just distribute, you rewrite it. The meaning of something squared is that it's 2x plus 5 times itself. And now you can do the FOIL. So you have 2x times 2x is 4x squared. Okay, and 2x times 5 is 10x. Then you have another 10x from the inner terms, and then from the last terms you get 25. Combine the like terms and you get 20x plus 25. Okay, last question on this page. So you have 3x plus 2 times 3x minus 2. And you may recognize this as a plus b, a minus b, and it's just a squared minus b squared. But if you don't remember it, just do the multiplication, distribute 9x squared. 3x times negative 2 is negative 6x. That's a positive 6x from the inner terms. And finally a minus 4. So these two terms wipe themselves out. That's a 0. So you have 9x squared minus 4 left. If you remember this from algebra, you can just skip the step entirely and just go from here to here. That is, you're remembering that a plus b times a minus b is a squared minus b squared. So this is a product of conjugates. These two terms are called conjugates of each other. Alright, the next question, rather than multiplying, we're doing the reverse of multiplication. So factoring is the opposite of multiplication. Here it says to factor out the greatest common factor from that expression. So look at each of these terms, starting with the numbers. 2 is common. If you look at the x's, you have x squared is common, y squared is common, z, there isn't a z here, z squared, so we can't take out anything because z is not here. Alright, so 2 times 2 is 4, and we took out x squared and y squared, z is left. 2 is taken out, you have x cubed, y squared is out, plus 3 out of x cubed is an x left, and z squared. And that's it. So in some cases later in calculus you will need to just take out a GCF and then go further with that, and that was an example of such a case. But in some cases you may actually have something more to do. So this is a problem where you have 4 terms. What you do is a technique called factoring by grouping, and if you don't recall this, you may want to look this up in an algebra book or online, factoring by the grouping method. But I will illustrate it here. Basically you split this into 2 groups. Now let's say we don't look at the second group. In the first group, what is the greatest common factor? It would be x squared. Take that out and you're left with 3x minus, there's a 1 left there because x squared times 1 is x squared. Now bring that positive sign down. Now let's ignore this portion, and there's nothing common between these 2 terms, so there's a 1 present. Put a little placeholder. The 1 is acting as just a placeholder. Now if you zoom out of this, you'll see that of these 2 terms something is common, and that something is 3x minus 1. So take that out, and then you're left with, from here, if that's pulled out, you have an x squared left, and from here a plus 1. Now this can't factor any further, so you stop. Well, one last question related to factoring is this one, where you have 3 terms, and what you do is the opposite of the foiling. It's reverse the distributive property, or reverse FOIL. You may recall FOIL is first, outer, inner, last. So you set up parentheses like you did in the previous page when the question was given in that form. I'm going to put x and x in those 2 locations because that gives you x squared. 6 can be thought of as 6 times 1 or 2 times 3. But we need a positive 6, which means that the 2 factors need to either both be positive or both negative, which rules out this possibility, because if these 2 are negative or both positive, they add to 7. We need a negative 5. So it would be negative 2 times negative 3 gives you positive 6. Negative 2 added to negative 3 gives you negative 5. So there you go. And that's how you factor that expression. The next question is a little different because you actually have an equation. You have equals 0. Let's find the real roots. Roots meaning the solution of this equation by factoring. So since this has 3 terms, it's sort of similar to this question. We have to factor it first, and then since you have an equals 0, you have to go and find the solutions. So 3x squared, I can do a little trial and error here. So here we have 3x and x gives us 3x squared. The question is this 4 going to be a 2 times 2, or will it be a 4 times 1? It's not as quick as that previous question. We actually have to do the multiplying to check it out. The sign has to be opposite. So let's say this is a minus and this is a plus. 3x times x is 3x squared, and then we have 6x minus 2x. That's not going to give us the middle term. So I'm going to cross that out. Now let's try 4 and 1. I'm going to place 4 and 1 there, and supposing I put the minus here and the plus there. 3x times x is 3x squared. Positive 3x minus 4x gives me the middle term. Minus 4 equals 0. So that's a good factorization. Now you may have seen this by a different method, the grouping method that we had seen earlier, where you break this up into groups. That's acceptable. If you've seen it by any other method that I have sometimes run into, the garbage method for example, please don't use it. It's mathematically wrong. Alright, to continue with this process, you now set 3x minus 4 to equal 0, and then you set x plus 1 to equal 0, and solve for x. Add the 4, divide by 3, subtract 1, and you have your 2 solutions. Okay, so that's how you solve. If you need any further help with questions like this, be sure to contact me via email or go to the Math Learning Center. Something you might want to consider is if you have a number in the front, then the factoring is a little bit more complicated and you might want to just use the quadratic formula. So unless I tell you to use a certain method, you're free to use whichever method you prefer. So here, the last question, we're solving by using the quadratic formula. And all that you're doing here is comparing this with ax squared plus bx plus c equals 0. So a is 4, b is 5, and c is negative 6. The formula is x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So it's negative b, which is 5, plus or minus the square root of 5 squared minus 4 times negative 6 all over 2 times 4. So it's negative 5 plus or minus, that's 25, minus, well, this is 16 times 6 is 96. It's a negative 96, so that makes it a plus 96. All over 2 times 4 is 8. So it's negative 5 plus or minus. So we have 96 plus 25, which is 121. Hey, 121 is a good number for square roots. It's just 11. And so you can keep going. It's negative 5 plus 11 over 8. Negative 5 minus 11 over 8. So this would be 6/8. And this would be negative 16/8. So we have x is 3/4, because 2 goes into the top and bottom, and this reduces to negative 2. So those are your 2 roots, or 2 solutions. End of lesson. Try the homework. Send me questions if you have any by email.